Hello and welcome to NOV Live. I'm Michael Gaines and glad you are joining us today as we continue our ongoing conversations, bringing you technical experts and insight into the world of energy and the technology that helps shape our world. So glad you're joining us today. And today's conversation will be focused on NOV's Drilling Agitator technology and what that looks like, especially as we look to combine that in the world of rotary steerable systems. So if you're interested in that conversation, we have a great expert here for you today. So thanks for tuning in and stick around as we'll jump into that conversation in just one moment. Before we do, we will head over to Shelby Dumaine to bring you up to speed on how you can be a part of today's conversation and also provide feedback on any of the episodes that you've seen here on NOV Live. So, hey, Shelby, good to see you.
Hey, Michael, it's good to see you too. I'm happy as always to be here joining the show. It's probably my favorite part of the week, so I'm excited for today's guest as well. So if you watching have any questions at any time about what you're hearing or what you're seeing for whether it's Michael or for our special guest later on, you can comment those questions below. Again, if you're on Facebook, LinkedIn, or YouTube, I'm in the comment section throughout the entire show, so I'm reading everything. I'm seeing now people are saying, hello, good evening. And so, if you want to say where you're viewing from, we can shout those out as well. I love seeing where everyone is tuning in from. But again, if you have a question at any point, that's also where you can comment those there. And like Michael mentioned, if you're watching maybe a past episode, or if later on you think of a question that you didn't get a chance to comment today, there are also a couple of different ways that you can reach out to us to still get those questions answered. The first way is you can email us at socialmedia@nov.com. That email is on screen now, so it's socialmedia@nov.com. And you can also give us a call. I've mentioned it before, but I love this option because you can stay anonymous, or you can let us know your name, maybe where you're from or where you work. And that number here is on the screen now as well. It is country code +1 346 223 4799. So you can give us a call there. We'd love to hear from you, and maybe even feature your question on a future episode. And then, like I mentioned before, if you have any of those questions that is for a past episode, we also have a place where you can go to view all of those past shows, and that is nov.com/live. So we've compiled them all there. If you want to view any of the past experts, and we've even had a show that's a similar topic to the one that we're discussing today. So if you want to view that as well, they probably will pair very well together. So that's available on nov.com/live as well. And now it's time for, again, probably one of my favorite parts of the show, which is the Rig Geek Post of the Week. All right. And the
Rig Geeks Post of the Week.
All right, here we go. So for those of you, if this is your first time watching the show, Rig Geek Post of the Week is where I'm going to ask all of our Rig Geeks there in the comments a bit of a trivia question. It also is kind of a clue for what the show is going to be about. And you might even hear the answer in the show, or maybe not, or maybe it might help you think of what the answer could be. So I'm going to ask you that question here in a moment. And then later at the end of the show, we're actually going to reveal it. So I'd love for you to tune in, stay tuned to see if you got the answer right. And with that, today's Rig Geek question is, can the agitator system be placed in tension, compression, or neutral point? So again, a little bit of a hint for what the show is going to be about, agitator systems. So can the agitator system be placed in tension, compression, or neutral point? If you think you know the answer, comment it below. And like I said, we will reveal that answer at the end of the show.
All right. Well, thanks, Shelby. Sounds like that's a good one. I like that. I have a little bit of background with the agitator system, but I want to see what our viewers have to say on that. So it's good. That's a good one for today. Thanks, Shelby. All right. Well, we're going to go ahead and jump into our main topic today. We are talking about NOV's Drilling Agitator system, and to give us some insight on this conversation. We have a guest today, Roman Chi. He is going to be joining us now from Houston. So Roman, thanks for joining us today.
Hello, Mike, and thank you for having me.
Absolutely. So I know that you are all in, especially when we're talking about the Drilling Agitator. So I know that it has been used in numerous applications and certainly in numerous BHA combinations. Specifically, we know that, of course, with a rotary steerable setup, that you've got continuous rotation there, and that helps solve a lot of the challenges that you would have seen with, or that you would have seen historically by just using, a bent motor and trying to do some sliding there. So what does the RSS do for operations for those that may not be as familiar?
Sure, we get this question quite often. It could well be one of the most common questions that we get from our customers when it comes to agitators in the RSS domain. Obviously, drilling agitators have made a big impact on the way directional welds are drilled today on mud motors. And from the get-go, it became clear that low amplitude axial vibrations that this technology creates can significantly reduce friction, especially when you slide. And over time, we validated additional benefits that this technology brings to RSS operations. And if I was going to break them down, I'm thinking of 4 main benefits. So if you think of rotary steerable systems, they are different from mud motors in a sense that you require continuous rotation from the surface, right? And that alone is supposed to notably reduce static friction and dramatically increase drilling rates. Now, the problem with that is even while you are rotating, there are still weight losses. And a certain percentage of weight is wasted thanks to side forces and dynamic friction before it actually reaches the bottom hole. So many occasions, we show that the drilling agitator actually helps improve weight transfer, even on the rotary steerable systems. Now, secondly, I'd like to touch upon torque transfer, because it could be counterintuitive, but even when you fully rotate the drill pipe, the torque transfer could still be compromised. So the drilling agitator, again, comes into play, and it can actually improve weight transfer to the bit. Another point worth mentioning is obviously shocks and vibrations, which could be damaging to many downhole tools, and RSS is not an exception. So they can actually cause the damage, and you could call it a premature trip. And finally, it's directional control that is greatly improved with the agitator on RSS. And I forgot to mention on shocks and vibration, one particular example of shocks and vibration is stick slip. It's very common, and many RSS are really prone to stick slip dysfunctions. So on many occasions, we show to our customers that drilling agitator actually helps mitigate stick slip.
So maybe let's camp there for a moment. So you said that the drilling agitator helps mitigate stick slip. So if we're thinking about vibration and in terms of some motion both from an axial and torsional modes, how does the drilling agitator system help mitigate stick slip? If I'm thinking about actually what stick slip is, how does it help in that space?
Sure. Let me first break down what the stick slip is, right? So stick slip is an extreme form of torsional vibrations, and it can be broken down into 2 distinct phases. And the first phase is called stick phase, where drill string RPM drop to 0. And the second phase is called slip phase, when the RPMs quickly accelerate, and oftentimes 2, 3, 4 fold of the average RPMs. So the agitator, as we all know, is very effective in breaking static friction. So if you think of stick events, each time the drill pipe almost have to overcome static friction. And during the stick events, the agitator does its job by breaking static friction. And that's how we mitigate stick slip. Another thing to keep in mind is the frequency of these dysfunctions. So generally speaking, stick slip ranges from 1 to 5 hertz, but most commonly stick slip events are present at 1 hertz or even less. Now, if you look at the agitator product family, the tool portfolio that we have features various tools that have frequencies from 7 hertz all the way to 20 hertz or even beyond. So if you think about stick event, there'll be at least 7 axial pulses that the agitator will produce and deliver downhole and uphole. Hopefully that makes sense.
Yeah, and that makes sense for sure. So for those that might just be joining us and wanting to know what makes sense, we're talking about the NOV Drilling Agitator system in Rotary Steerable system or RSS applications. And so we've got our guest Roman here. So if you have any questions on the NOV Drilling Agitator system and how that applies in a Rotary Steerable application, feel free to put your question in for Roman, whether you're watching us on LinkedIn, Facebook, or YouTube, and we'll try to get your question in just a little bit. So, Roman, one of the things that also that I've read and understand about using the drilling agitator system, especially in conjunction with an RSS, is improved directional control. So the ability to have a tighter control over the overall direction of the drilling program. So what does that look like, and how do you what are you kind of narrowing in when you say that it can help with directional control?
Sure. Many customers report that with the agitator in their RSS applications, they see improvement in directional control. And my answer is somewhat related to stick slip mitigation. So if you think of RSS, heart and brain of the RSS, there is a component that is called bias unit. And in the event of high stick slip dysfunctions, the bias unit struggles to assess where the tool is actually headed to. And in order to adjust steering parameters, additional communication from the surface may be required with the tool. And directional drillers normally do that by means of special commands that are called downlinks. Simply put, downlinks is just variations in flow rate that very smart tools downhole could decipher and respond back to the surface that they actually understood what's required from it. So in the event of high stick slip, you need to send additional downlinks, and some of these downlinks would have to be repeated. Yes, certain RSS tools are capable of downlinking on the fly while remaining on bottom, but in many cases, you still have to dial back parameters. So all these little things make up some hidden non-productive time, right? This is where the agitator comes into play again. Like I said, it helps mitigate stick slip, and by doing so, it actually reduces this NPT and it eliminates these unnecessary downlinks, right? And second part of the answer is directional response. It becomes more predictable We hear many operators reduce flow rate because of more superior directional response that they're getting from RSS. So because of predictable turn rates and build rates that they're getting on RSS, there is no longer a need to push harder on RSS pads or pistons. And that's what the agitator enables them to do, basically get better directional control and even cut back parameters.
So there's been a phrase that has been around for a little while. Some folks might be familiar with the acronym Hfto, or high frequency torsional oscillation. So a specific characteristic that happens in some applications. Can you maybe talk a little bit about what that is, what Hfto is, and also how the NOV Drilling Agitator system plays a role in that space?
Sure, I can. So to put things into perspective, I'd like to first break down, the types of torsional vibrations. So earlier in this conversation, I mentioned stick slip, and stick slip is a form of so-called low-frequency torsional oscillations. And LFTO, or low-frequency torsional oscillations, is simply any RPM or torque variations along the drill string. And this is a natural process, and the longer the well, the more drill pipe you have downhole, the longer it will take for top drive RPMs to become equal with the drill bit RPMs, right? Now, on the flip side, there is a relatively new term which is called Hfto. I think it was coined about 5 to 10 years ago, and it's different from low frequency torsional vibrations in many ways. By definition, it can be described by very high frequencies, anywhere from 30 hertz all the way to 500 or even 700 hertz. This dysfunction is also generally present in harder formations, especially when the driller applies more aggressive parameters. And it's very often, it very often coincides with very efficient drilling. And if I was to give you an example of Hfto related incident, then it would be something like this. The driller would drill ahead. He or she would apply high weight and RPM. There'll be very efficient drilling, and all of a sudden, there could be a catastrophic failure. There could be a loss of torque, pressure, and ROP. So this is an extremely challenging dysfunction, and because of its extremely high frequency, it's almost impossible to detect it real time. And even after the fact, it's really challenging to pinpoint it. The problem with that is that all the downhole tools have limits on the sampling frequencies. And for that, you need special high frequency tools in order to measure them. So earlier, I said that Drilling Agitator enables many operators to reduce parameters and yet achieve the same level of performance. So that alone should reduce the likelihood of Hfto. And if I may, just one more comment here. Just wanted to share some of the most recent developments, because we as a company invest quite a bit of resources and time in better understanding this phenomenon. And lately, we partner up with a company whose day-to-day activity is lab testing and research into this kind of drilling dysfunctions. And based on their initial assessment, it's obvious that the axial agitation actually impacts Hfto magnitude. So that certainly warrants further tests. We'd like to see what we could do, by varying the agitator frequency, coupled with variations in weight and RPM.
Right.
So we'll certainly keep you all posted on how this project unfolds.
Yeah, please do. That's a really interesting interesting observation. So one, I know that like any tool, the drilling agitator system has to be not only used properly but placed properly. In this case, especially when you're looking at the drill string and the application, and all of the things involved. I know that when you then take the step further and start looking at rotary steerable applications using the drilling agitator, that there's got to be some specific considerations on top of what you would if it were the difference between maybe a standard BHA and an RSS, so or even a bent housing motor. So could you talk a little bit about what the considerations and thoughts are that go into using the drilling agitator with an RSS system?
Sure. In terms of placement, we typically follow the same process. We are looking at the agitator placement from the operator's vantage point. We want to assess what's really required from the tool, and in conventional motor applications, if the problem is friction, which is normally the case, we typically try to place it in the area of the high friction. And it could be anywhere from 2 to 5,000 feet. On rotary steerable VHAs, we follow the same process. And if the problem is with string-driven vibrations or torque, then higher placement is also justified. But on the flip side, if the challenge is bit or BHA generated stick slip, then the placement has to be much closer to the BHA. So essentially, it all comes down to proper pre-job planning, where continuous and direct communication with operators and service companies is really vital.
Mm. So, you've talked about operators a few times in our conversation. I know we haven't spent a specific amount of time talking about that, but I did want to turn our focus slightly in that direction. So when an operator is looking at running the agitator system in conjunction with an RSS, what are some of the things both that you hear from them that are concerns and things that they can keep in mind when considering incorporating this in their overall drilling program?
Sure. There are really no restriction that this tool adds to the operations. Well, there are just few points of emphasis that we'd like to highlight whenever we engage in planning projects with our customers. First and foremost, this technology consumes energy to create the energy, right? It converts hydraulic energy to create axial movement, and for that there is a pressure drop involved, and it could be anywhere from 350 psi up to 600 plus psi. So depending on the application and your location, we could offer the best tool and the best system and setup. In terms of drilling parameters, we don't really impose any restrictions. The newer designs that we rolled out recently feature heavy-duty connections. Their specs actually exceed those of drill pipes currently on the market. I'm thinking of flow rates. In extreme flow rate applications, we recommend a new tool that we rolled out last year. It's called Agitator Surge. And this tool is quite something. Say in the 7-inch size, we could pump all the way to 1200 GPM. And I can tell that it's not easy to replicate it. And today there are no other friction reduction tools that could feature this kind of flow rates. And maybe finally, in terms of solids and low circulation material, density and size, again, those restrictions wouldn't come from the agitator system. They would rather come from more delicate tools below the agitator system, and those would be MWD motors and RSS in particular.
Hmm. Well, I think this has really been helpful in understanding, especially from a rotary steerable standpoint, as was the focus of our conversation, how the drilling agitator system can play a role. There were some questions that came in that I think, of course, I could try to answer, but that's why we have you here, Roman. So we are going to go ahead and bring Shelby Dumaine in to get some of those questions answered from our viewers.
Absolutely. Hey, Michael. Hey, Roman. So we got this first question from Gavin Olney on LinkedIn, and he was wondering, can more than one agitator be placed in the string?
Yes, it's actually a good question. And in fact, we've had quite a few runs under our belt where we run dual agitators. We typically run no more than 2 agitators because, any additional one would put too much strain on the standpipes.
Mm-hmm.
But if we are planning a long lateral or a very complex 3D well, then certainly the second agitator is justified, at least to entertain that idea. Because as we all know, the agitator is a source of axial vibrations. But as they travel, as the pulses travel in both directions from the tool, they tend to, reduce in their magnitude. So for that, the secondary tool may be required.
Mm-hmm. Absolutely. And then this next question, I'm kind of taking it based on one from Syed on LinkedIn. And could you talk? So we've talked a lot about kind of the agitator in use with the RSS, but can you talk a little bit to what RSS drilling is? Sometimes we have audience members that maybe aren't as familiar with that type of operation. So could you speak a little bit to what that is as well?
Sure. Yeah. RSS drilling came to the market about 30 years ago, if I'm not mistaken, and they kind of revolutionized the way drilling was conducted back then. So conventional drilling is done on mud motors, and in order to drill directional wells, you need to go through 2 cycles, sliding with the motor when there is no rotation from the surface. And it's typically followed by the secondary phase, which is rotating when you have to turn on the top drive RPMs. So the problem with mud motors, on top of all the benefits and advantages that it actually presents, there are also some drawbacks. One of the biggest drawbacks to the motors is that during sliding, you have to overcome significant amount of friction because the pipe is basically stationary. Now, what the rotary steerable systems do, those are more advanced systems. They have, top-notch electronics, and you can actually communicate with the tool real time, and the tool would steer itself in the given direction. But in order to operate the RSS, you have to continuously rotate from the surface. In a nutshell, this is 101 on RSS differences from the mud motors.
Well, I definitely appreciate the anytime I can get a 101 on anything, I love hearing that. That kind of helps put everything in context for me as well. So it's kind of speaking of, again, RSS, agitator, all this. Can you tell us a little bit about agitator's track record with RSS?
Yeah, absolutely. We are actually a little bit shy of reaching one of the biggest milestones, I think, within downhole, maybe even within the entire NOV. We are just a little short of hitting 100,000 runs. We were on track on, hitting that milestone back in 2020, but for obvious reasons, pandemic hit. This kind of pushed it back, and hopefully towards the end of 2021, we should be hitting that great achievement, and we're really proud of it. But we're not yet there, so we'll look forward to it for sure.
I'm sure it'll come sooner than later.
Absolutely, sooner than later.
Well, I think I'll do maybe 2 more questions actually here. So we just got one in from Pablo on LinkedIn, and I know sometimes you can't say exactly location, sometimes you can. So feel free to answer what you can. But he's wondering where the agitator with RSS has been proven. Maybe what type of environments or general regions, I guess.
Sure. The our geography is pretty wide. We've had runs, obviously, in North America, in the US. We have proven the concept, and we've clearly demonstrated the benefits of the agitator in RSS domain in the Middle East, in Asia Pacific. We had runs, very successful runs, in Russia, as well as Latin America. So I think the only place where we haven't had any runs could be Australia.
Wow, that's great. I appreciate the variety of geographies, and within that, the variety of applications that represents. That's good to hear.
Absolutely. Agitators all over the world. I love it. And so this last question, and it kind of is perfect because we normally kind of ask this at the end of the show anyways. So I'm going to steal this question from you, Michael. Is Marek on LinkedIn was wondering, he was looking for maybe more drawings, more pictures, more information. So where could he go either to contact someone for more info or maybe to see it online?
Sure. You can certainly contact me directly, and hopefully we could post my contact info. Other than that, please follow the link at our official webpage. We have a page dedicated to agitator technologies, in all applications, conventional and unconventional applications. It's nov.com/agitator.
Perfect. Yeah, there it is on screen. Yeah, nov.com/agitator. Great. Well, those are some good questions. Thanks for ringing those in for us, Shelby and Roman. Thank you for answering that. So we've been speaking with Roman Shea, who was representing the NOV Drilling Agitator system. He's the global product line manager for Drilling Agitators. So appreciate Roman being with us. And before we close out, of course, we want to get the answer to our Rig Geek post of the week. Mm-hmm. So Shelby, I know that you're always one to scribble some real fast notes as our experts are talking. So I hope that your answer and the answer of our guest match up.
Absolutely. I did see a few guesses on there, and I will confess we did ask a bit of a trick question this week. I can't help it. So that question one more time, I asked, can agitator systems be placed in tension, compression, or neutral point? And of course, the trick question here is that the answer is yes to all 3. So agitator systems can be placed in tension, compression, and neutral point. I do have a caveat. The caveat is to ensure that the shock tool is within the recommended operating range. Otherwise, it might stroke open and close. But other than that, yes, the answer was to all 3. It can be placed in tension, compression, or neutral point. So thank you, all of our Rig Geeks in the comments, for answering. And I do apologize for trying to...
Yeah, that was one of those trick questions that, what is it? Not even the answer is C. The answer is all of the above.
Exactly.
So, well, that gave me shudders from high school, but that's all right. Well, cool. Well, thanks, Shelby. I appreciate the help there, and certainly a thanks to our audience for joining us. And again, thanks for Roman for joining us today. So if there are technologies that you hear about or read about in journals or even hear about from NOV that you'd like to see featured here on the show, or want an expert to come on the show live to answer your questions, feel free to drop us a line. We are an open book and always happy to receive your feedback and thoughts on technologies that are relevant to you, relevant to your business, or you'd just like more information to understand how it can benefit you. So if you have questions, feel free to drop us a quick email. And that email address is socialmedia@nov.com. And again, as Shelby always says every week, she and I and others regularly monitor that inbox. So we're more than happy to receive your comments, ideas, or suggestions. So from all of us here at NOV, thanks for watching and for listening. And we'll talk to you again next time.